Hi, this is Math 1350 and this video is over section 5.1. We're going to introduce trigonometry identities and looking at how we simplify or even prove identities. So I won't lie, this chapter is one of the hardest. Unless you start to really like doing it, then it'll make it a little bit easier. Once you wrap your head around it. I love doing these, but I understand how they can be. We're going to start with some basic identities and prove them, and then once we prove an identity, we can kind of use it whenever we need to. It becomes something we can always use if it's one of the useful ones. Right, and so first, some definitions. Sine theta equals y over r, cosine theta equals x over r, and tangent theta equals y over x. So that's with a trigonometry triangle. This is x, y, and r. Okay. And so we're going to start with proving some of these basic identities using these definitions, right? So we always want to make the left side equal the right side when we approve this. When we prove these. So first, the quotient identity. Tangent theta equals sine theta over cosine theta. All right, so sine theta is y divided by r. Cosine theta is x divided by r. And so the r's cancel out, and we get y over x, which is tangent theta. And so we made one. We went from one side and moved it all the way over to the other side, or to equal the other side. Right, doing the same thing with this next one. This next one, there's a mistake. It's not tangent. It's cotangent. Cotangent theta equals cosine theta over sine theta. And so we'll start with cosine and sine. This is going to be x over r, and y over r. The r's will cancel. You get x over y, and x over y is the definition of cotangent theta. All right, we're going to show that cosecant theta is 1 over sine. And so we'll start with definition of cosecant theta is r over y. And well, actually I want to start the other way. Start with 1 over sine. I'll do it this way. 1 over sine theta is 1 over y over r. And so when you divide by a fraction, you flip it. So this is r over y, which is cosecant. Let me write this better. Cosecant theta. We'll do the same thing with cosine. 1 over cosine is 1 over x over r, which becomes r over x, which is secant theta. And then with tangent, 1 over tangent is 1 over y over x, which becomes x over y, which is cotangent theta. Now we're going to prove these Pythagorean identities. Sine squared plus cosine squared equals 1. I'll tell you this is one of the most important ones. Tangent theta plus 1 equals secant theta. Notice tangent and secant, this is common that they go together. And then cotangent squared plus 1 equals secant squared. These are common that they go together. In each of these, notice the tangent is squared and the secant is squared and the cotangent squared and the cosecant squared. That's important. I've seen a lot of people, they see tangent plus 1 and they start thinking, well, that's secant. That's not necessarily true. This has to be tangent squared plus 1 equals secant squared. Okay, so we'll start with sine. And sine squared plus cosine squared. So this is going to be sine is r y over r, and it's squared, plus x over r, and that's squared. And so this will get y squared over r squared plus x squared over r squared. We can write this as y squared plus x squared over r squared. Then y squared plus x squared is r squared. That gives you 1. Right, that's just the Pythagorean theorem there. X squared plus y squared equals r squared. Get a little line separating these. Right, so for tangent squared plus 1, tangent is y over x. So it'd be y over x squared plus 1. So y squared over x squared plus 1. And then I'm going to find a common denominator. So y squared over x squared plus x squared over x squared. And so this becomes y squared plus x squared over x squared, which is r squared over x squared, which is r over x squared, which is secant squared, secant x squared. And then the last one, done very similarly. Cotangent is x squared over y squared plus 1. Get a common denominator, x squared over y squared plus y squared over y squared, which is going to be x squared plus y squared over y squared, which is r squared over y squared, which is r over y squared, which is cosecant squared. Oh, these should be thetas. That part at the end. Okay. With what we're going to be doing, it's common to use some algebra stuff that can come up. So some common things. One is factoring. Notice you can factor out x. You get x plus 5. We may have to do that with sine, cosine, or tangent. Difference as 2 squares will come up a lot. So that's just y plus 1 times y minus 1. Or even difference of 2 cubes, which is going to be a minus b times a squared plus ab plus b squared. And then also a cubed plus b cubed. It's going to be a plus b times a squared minus ab plus b squared. Right, so factoring is common that you have to do. Also, finding common denominators is going to be common. So 2x plus 3x over x gives us 2 plus 3x over x. Or having to cross multiply to find the common denominator. So this will be x minus y over x plus y times x minus y. And this will be 2 times x plus y over x minus y times x plus y. These are the same. I know I wrote them out of order, but they're still the same. So we have x minus y plus 2 x plus y over x plus y times x minus y. And so we'll distribute the 2. So x minus y plus 2x plus 2y over x plus y times x minus y. And then combine like terms, so we'll have 3x minus y over x minus y, x plus y. And then here again, find common denominator. So we'll multiply, in the one side we'll multiply by 3x. So we have 6x squared over 3xy. And then this side we'll multiply by y, so we'll have 4y squared over 3xy. And so this becomes 6x squared minus 4y squared over 3xy. And we can factor out a 2. So 3x squared minus 2y squared all over 3xy. Just some common algebra math things that will come in as we go through these examples. So one thing we're going to look at is simplifying trig expressions. When we say simplifying, we mean no fractions if possible. And the least number of terms. Sometimes you can avoid a fraction, and sometimes you can only get down to so many terms. But you try to do your best to get to reduce these things, to reduce the terms or to reduce the fractions. Right, so we have cosine squared over sine plus sine. Okay, so because I have a fraction on one side, I have two things adding. In order to add these, I have to find a common denominator. So I'm going to multiply the second term by sine x over sine x. So I have cosine squared x over sine x plus sine squared x over sine x. And so I can put these together. I get cosine squared x plus sine squared x over sine x. And this is a trig identity. Sine squared plus cosine squared equals 1. Right? It's one thing that comes up all the time. And so this becomes 1 over sine x, which is cosecant x. And so no fraction, one term, that's the best you can get. Right. So here we'll have cotangent theta over cosecant theta. Now, a lot of times one thing you want to do with these is try switch things to cosine and sine. Because tangent can be expressed in cosine and sine, cotangent can be expressed in cosine and sine, as well as cosecant and secant. So a lot of times that's just what we do, is try to get these in cosine and sine and see what cancels. So cotangent is cosine theta over sine theta. Cosecant is 1 over sine theta. And so this becomes cosine theta over 1 because the sines cancel. And so this becomes cosine theta. One term, no fraction. Okay, so we have 1 plus sine theta over sine plus cotangent theta minus cosine theta over cosine. Right, so what we're going to do is find a common denominator. So I'm going to multiply the left fraction by cosine over cosine. So I have cosine theta times 1 plus sine theta over sine theta cosine theta. And then the other fraction I multiply by sine over sine. So cotangent theta minus cosine theta times sine theta over sine theta cosine theta. Okay. Then on the top I'm going to distribute as I put this into one fraction. So cosine theta plus cosine theta sine theta plus cotangent theta sine theta minus cosine theta sine theta all over sine theta cosine theta. Okay, now we have cosine sine, negative cosine sine. These cancel with these. Okay, not with the bottom, but on the numerator they cancel each other. They add to 0. And so this becomes cosine theta plus, now cotangent theta, I'm going to rewrite that as cosine theta over sine theta times sine theta and over sine theta cosine theta. And we can see sines cancel. And now we have just 2 cosines on the top. So we write 2 cosine theta over sine theta cosine theta, which the cosines cancel. We get 2 over sine theta or 2 cosecant theta. Again, one term, no fraction. We could have took, I'm going to do it in a different area. We could have tried to do something different here. Maybe we could have split the fractions up. So we end up with 1 over sine. Sine over sine is 1 plus cotangent theta over cosine theta minus 1, which then gives us 1 over sine theta plus, and I'm going to switch this to cosine theta over sine theta cosine theta, which then cosine thetas cancel out. We get 1 over sine theta plus 1 over sine theta equals 2 over sine theta, which equals 2 cosecant theta. So there's other ways you can go about it. Alright, and it seemed like maybe at the start, okay, I'm switching this to 4 terms, but then things started canceling. And sometimes you will try a way and it just doesn't work out that there's any possible way of going about it. So here, one thing we gotta notice in number 4 here, sine squared minus 1, that's the difference of 2 squares. So we gotta split that up. Sine squared theta plus 1, sine squared theta minus 1. And then the bottom, we're going to factor out a tangent. And so we have sine theta minus 1. Right. Sometimes it's just easy to, if you see it, you just have to see it, kind of see commonalities between numerators and denominators and see what cancels. Right, here we can see sine, these shouldn't be squares, sine theta plus 1, sine theta minus 1. And so these cancel. And so we have sine theta plus 1 over tangent theta. I can split these. Sine theta over tangent theta plus 1 over tangent theta. Tangent theta is sine theta over cosine theta. And this is going to be cotangent theta. And then this, the sines cancel out, so you end up with just cosine theta on the top plus cotangent theta. Okay, now no fractions. We have two terms. I don't think we could make it down to one, and so this is the best we can do. Right, I'm going to stop here. In the next video, we'll continue this with actual trig identities. See you then.